Welcome back. This is Emmett, and in today's video we'll be tackling this problem. So we have to determine the sum of this infinite series. So pause the video, try it out, and get back to the video when you're ready. Okay, so the first thing that might jump out at you is that the denominator here is a polynomial that can be factored. So let's start by doing that. And that leaves us with this. What we can do now is partial fraction decomposition, which will reveal the answer. So let's set that up. For now, I'm going to ignore the sum sign since I'll just be manipulating this fraction right here. So as the numerator, we're going to have a constant times n plus 5 plus another constant times n plus 1 all over the same denominator. And then what we're going to do is we're going to break this up into two separate fractions. So we'll have a times n plus 5 over n plus 5 times n plus 1 plus b times n plus 1 over n plus 5 times n plus 1. And what we can do, as you can see now, is cancel these. And that leaves us with a over n plus 1 plus b over n plus 5. And so now all we have to do is find a and b. So if we look back up here, we see that this top part of the fraction is going to have to equal 4, since we're only manipulating, we're not changing the fraction. So what we can do is set up a system of equations up here. So I'll have a times n plus 5 plus b times n plus 1 equals 4. And now what we can do is solve for a and b. So let's first solve for a. We can see that when n equals -1, this whole term here is going to disappear. So let's write n as -1 first. So a times -1 plus 5 will be 4, plus b times -1 plus 1 equals 4. And so as you can see, we have a times 4 equals 4. So a equals 1. And we can do the same process for b. So we'll have, we see n equals -5 will make this whole term disappear. So let's plug in -5. a times -5 plus 5 plus b times -5 plus 1 equals 4. And so we get -4 times b equals 4. And so now we get b equals -1. And now what we can do is plug a and b back into the original two fractions. So that gives us 1 over n plus 1 plus -1 over n plus 5. And now I can add the sum sign back onto the front because we are working with a sum. And now with the space cleared and this written a little neater, you might be able to recognize that this is actually a telescoping series. So writing out the terms of this series will reveal which terms cancel. So let me do that. You might be able to see that the subtracted terms always get canceled out later down the line by the positive terms. So the -1/6 gets canceled by the +1/6, the -1/7 by the +1/7, the -1/8 by the +1/8, etc. And so all of these subtracted terms are going to end up getting canceled out by the positive terms, which also means that all the positive terms are getting canceled out. And so all of these terms cancel except for the +1/5, 1/4, 1/3, and 1/2, since the first subtracted term starts at -1/6, and so these terms never get canceled. However, the rest of the terms do. And as the terms grow, they approach 0, since these two terms approach 1 over infinity. And so that leaves us with only these terms getting added together. And so 1/2 plus 1/3 plus 1/4 plus 1/5 equals 77 over 60, which equals 1.283. And so that is the sum of this infinite series. Hopefully you found the use of partial fraction decomposition with series interesting. As always, thank you for watching.